Okay, so in this video, we're gonna answer this question. So first of all, remember the two golden rules for ideal op-amps. The voltage at both input terminals is equal, and no current enters the op-amp. In the first circuit, the inverting terminal, this inverting terminal, is 4 volt. So which means this will be also 4 volt. Okay, and then the next step is we just apply the KCL at node A. So 1 equals to 4 minus V0 divided by 2k ohm. So we just gotta solve it here, which lead into 2 equals 4 minus V0. Okay, so which means V0 equals to 4 minus 2, V0 equals to 2. Okay. And then for problem B, for the second circuit, the positive terminal is at 3 volt. It is 3 volt. That means the inverting terminal the inverting terminal is also 3 volt. So 3 minus V0 equals to 1. That makes V0 equals to 2 volt. Okay, so this is for the number 2. Let's solve for the gain V0 divided by Vs. V0 divided by Vs. Okay. So first, look at the non-inverting terminal. This one. Okay. Since no current flows into an ideal op-amp, there's no voltage drop across the 20k ohm resistor. That means the voltage at the plus terminal is just Vs. Now notice that the output V0 is connected to a voltage divider with two 10k ohm resistors. The voltage at our minus terminal is taken from the middle of these two resistors. Using the voltage divider formula, Vs equals to V0. It means 10k divided by 10k plus 10k equals to V0 times a half. So the final result is V0 divided by Vs equals to 2. So this is for the question number 3. This is for number 3. Problem number 3. We need to determine the output V0 for this summing and amplifier. Don't let the multiple inputs will handle. Notice the non-inverting terminal plus is grounded. For an ideal op-amp, that means our inverting terminal is virtual ground or 0 volt. According to KCL, the sum of the currents coming from our 3 source must exit through the 30k ohm feedback resistor. No current enters the op-amp itself. The formula and inverting summer is simple. V0 equals 2 minus Rf times like this V1 divided by R1 plus V2 divided by R2 and then V3 divided by R3. So just gonna input the number which in here in 30k. I'm sorry, I mean not this one, I mean this one. Wait, this one. Okay, minus 30k equals to 2 volt. Okay, plus 4.5. Okay, so the final result will be V0 equals to minus 30k times 0.2.5 MA, which will be minus 7.5 volt. Okay, that's for number 3. This is for number 4. In problem number 4, we are looking for the current EO. To find it, we first need to determine the voltage at the op-amp nodes. The non-inverting terminal is at 0.4. Let's apply KCL at the inverting node. The current living through the 10k ohm resistor plus the current through the 50k ohm feedback resistor must sum to 0. So, which means 0.4 minus 0 per 10k plus 5 0 plus 50k equals to 0. It gives 2 plus 0.4 divided by 0 minus so V0 equals to 2.4. And now we have to calculate the IO. This is the this is the IO. Okay. I0 is the sum of two currents, the one coming from the 50k ohm resistor and the one going through the 20k ohm load. The math is which equals to 0.04 mA times 0.12 mA, which results to 0.6. Okay, thank you for listening, guys.